It is my pleasure to introduce our first keynote speaker for the conference, Mr. Carl Page. Mr. Page is the co-founder and president of the Anthropocene Institute. He was the founder of eGroups, which built a network of 14 million users to support web-based collaboration. He is a serial entrepreneur and investor and has a master's degree in computer science and engineering from the University of Michigan. Please welcome Mr. Carl Page.
Thank you, Monica.
Thank you.
And thanks, Jenny, also for inviting me here. I'm really excited to be talking to you all. I've been learning a lot about nuclear power over the last decade, especially that I've been focusing on climate change and clean energy. My experience, I started off in computer science and computer engineering at Michigan, as was mentioned, and worked on a number of different companies doing work in CAD/CAM. I started off at Mentor Graphics because it was exciting to be working in a new language called C++, and I decided that was a terrible idea. I'm never going to do that again at some point. And my new business partner, Scott Hassan, told me about this new language, Python, and he had made this web archiving tool for Python, and it was beautiful. And we decided to make that a service, and it became the first website in Python. It was eGroups.com eventually, and that was quite successful. And it's given me some opportunity to do good things for the world without worrying about a paycheck. So I think it's kind of ironic that the beginning of two new computer languages led me in interesting directions. I'll make my slides online. I tend to be one of those people that have way too many slides, and I know that can be frustrating. A few words about the Anthropocene Institute, which I founded with my wife, Barbara, about 8-9 years ago. We are mostly working on climate change. We got distracted some by the pandemic, like a lot of people, and did some projects there. We have 3 main ocean projects, making aquaculture sustainable, hopefully someday, getting off fish feed, and helping protect the nurseries for fish that are the marine protected areas. And in clean energy, in all cases, we try to do things that are neglected, things that other people won't do. And nuclear power, innovative nuclear power, and innovation in general is something that is really a challenge. So we play all the keys on the piano. We use investments in startups. We hire consultants and engineers and laboratories to work for us. We work with academic researchers, and we work with press and PR people, and trying to find messages. I'm on the board also of Eco America, which is a unique organization. I like to say most scientists don't know that scientific marketing exists, and it does, and it's really important to, if you're doing the Lord's work and everyone hates you, the problem is you suck at PR. And I think this room can appreciate that. So we need to do better there, and I'll have some words about that. Now, I often don't it's a stupid idea to come scare people or try to at the beginning of a talk, so I'm going to do it anyway. There's a real chance if we don't get our act together that we'll have to visit our favorite giant cities like Tokyo or Bangkok or New York, Long Beach at least, and by scuba diving. And that's not a small threat, and it's soon. The other day, I read in Nature a peer-reviewed paper saying that by 2050, Vietnam might be almost completely underwater. And well, maybe the people can walk uphill, the rice paddies can't. So 2050 is a time when I might even still be alive. So anybody who tells you that net zero by 2050 is a good goal is smoking something. Because, we have too much CO2 in the atmosphere now. And if we stop emitting today, it's going to keep getting warmer for a long time. And these catastrophes will keep happening. So we need to be, net negative, not net zero, and soon. It's almost like, there was this movie, Don't Look Up, and, about scientists at Michigan State University discovering an asteroid is heading towards Earth. Well, so after we successfully deal with that problem, the sequel needs to be Don't Look South. Oops, I forgot to advance my slides. And that Don't Look South is all about what if scientists from Michigan State University discover there's a glacier in Antarctica called the Thwaites that's on land but might be heading for the ocean. What would governments and industry and Wall Street do to confront that threat? Because unfortunately, that's not a myth. And we really need to be taking it seriously, and the institutions are not going to. When I do look at things to set my clock on what kinds of action I think are appropriate, I usually look at ocean acidification, because greenhouse gas warming is complicated. It relies on models, and pathological skeptics can always say your model is wrong, and models are intended to be wrong. They're simplifications. So it's too easy to deny. But the beautiful thing about ocean acidification is it's sooner and simpler than greenhouse warming, because the most important question you'll ever be asked may be, sparkling or still? The ocean dramatically prefers still, not sparkling, and you can do the experiment yourself, buy an aquarium, and see how long the fish last if you turn off the bubbler. And the problem is the ocean is getting to that point. And we've reduced its pH by 0.11, and we can't keep doing that. The plankton is going to have to change its way of life, and the plankton will choose a different way of life. In the past, a couple times, it's chosen to make hydrogen sulfide instead of oxygen. And every other breath that you take is oxygen from the ocean, plankton. And it can stop, and if it makes hydrogen sulfide instead, every warm-blooded creature on Earth has to die. The ocean won't care, but let's not leave it that choice. The thing is, when there's a threat that threatens everyone, we take it less seriously because it seems fair. If somebody was trying to, kill you personally, but not everybody else, you might be more tempted to care. We need to get rid of that. Any threat to your person should be considered depending on what threat it is, and you need to spend a little more energy on it. And you guys in the room are doing the right thing, but for communicating with others, it's important. I'm worried that we're setting our aspirations way too low. If you need to take a step and you take a half step, that's called a face plant. And the most dangerous thing is that we'll do things like aim for net zero in 2030, which are inadequate. We'll get what we ask for, and we'll fail as a civilization. We should ask for things we actually need. This first picture, when Haiti had an earthquake, the United States sent an aircraft carrier there to provide electricity and water. And that was fantastic. But that ship had about 1,000 more sailors than we need for the job and an awful lot more weapons. Where is the emergency preparation ship that can provide water and electricity at the drop of a hat? That's a commercially built one that's a lot cheaper. We should demand things like that. We don't want another Puerto Rico having a hurricane and sitting around there for years not having electricity. We owe it to ourselves to have a modern society, and that means electricity. How are you going to recover or run your hospitals? And there's a lot of fossil fueled vehicles that we cannot replace with electric. We can provide synthetic fuel for those using nuclear power and waste carbon that's going into the atmosphere quite easily. And there's a bunch of startups trying to do that, and that's something we need to do. We need to make a lot more room available for biodiverse nature, and that means shutting down bad things. Leadership is not about getting good things to happen as much as it's about shutting down the things that shouldn't happen. I love President Obama for many reasons, but his energy policy was really terrible because it was all of the above. The first thing you got to do is shut down the bad things. So we need minerals. We need, to make solar panels and wind turbines and magnets, motors. We need fertilizer. All that needs to be done carbon-free. And the 100% renewable zealots don't have any answer for how we do any of those things. Where can I buy a solar panel today made with solar power? If it's really the cheapest, they should all be made that way, right? If it's unavailable, that tells you something. And that will change over time, perhaps, but the problem is time's up. We need to really be changing our way of life quickly. And of course, people complain about a water shortage. That's a really good hint for the nuclear industry. In California, people are not that worried about electricity. We're really worried about water. So why is the nuclear industry not selling water first? That's one of the reasons I mentioned that water ship at the beginning. The political will is often mentioned as a problem that's blocking progress, but the political will's there. I have more on this later, but Germany, for example, raised all the money that it needed to totally decarbonize its economy recently. And Ontario did as well. And, well, not totally. The power grid in Ontario just recently got decarbonized, and I'm very excited about that. In Germany, they bought so many solar panels that because of volume price declines, they managed to make solar cheap for the whole world, and that's a fantastic victory. And that really deserves credit. Because solar may not be powerful enough for industry, but it's beautifully distributed. So every house should have a solar panel on it just in case the grid fails, so you can still run the basic essentials of life. And rural electrification should be mostly solar. It's too expensive to keep power lines going to remote locations when it's so much cheaper to have solar panels. But Germany is a cautionary tale because they didn't get the negative carbon they paid for. And that's because there was some boondoggles going on. They bought solar panels, sure, but it's a cloudy country and they didn't make that much power. And they also allowed Putin to sell them a lot of gas to balance out the solar panels while they shut down their nuclear plants. And Putin turned on even more nuclear plants so he could sell more gas to Germany and keep them on a very short leash, hoping to earn their support geopolitically, which almost happened. And I think if it hadn't been for President Biden's leadership, having a call to Jesus meeting in Rome, it would have gone very differently. You've got Gerald Schrödinger, the ex-chancellor of Germany, refusing to sell his Russian oil company stocks. And, oops, I should move my slides. I have two clickers here. Refusing to sell his oil stocks, that tells you something. We really need to work hard to prevent corruption. And I think, it's not about energy security, it's about security. When we let our energy supply be controlled by people that are opposing our success, then we're going to get in bad trouble. We've had 100 years of bad people in charge of our energy supply. It's time to move to something safe and domestic. So, my modest proposal is, it's not just greenhouse gases and ocean acidification that are going to kill us. Sadly, there's a list of at least 10 kinds of pollution that pose existential threats to humanity. The good news, though, is we know how to fix all of these. It's not even complicated. It just kind of looks expensive if you're expecting that coal-fired power is supposed to be the cheapest we'll ever see, because we cannot clean up sprawl and garbage and germs, runoff, the overabundance of fertilizer if we are relying on coal-fired power. And we can't do it if we use nuclear power that's the same price as coal, which is part of the reason the light water reactor was so successful. Didn't rock the boat for anyone. We also just need, as a goal, not an aspirational thing, but a serious thing, we need to make sure that climate scientists believe that our climate is safe for 20 years. Because that's about the time it takes for a new team to take over. You guys are the new team right now, and we don't want the climate to die just as you get responsibility for it. So right now, no climate scientist can say with authority that we have 20 years, because there are tipping points that we're dangerously close to, and we need to get that under control. That's why we need to bring greenhouse gases down from 440 ppm down to more like 280. And nobody thinks that's possible, but it is. So the secret is, if you want a lower price, buy more. The energy industry is not going to voluntarily reduce prices on energy because they don't want to reduce profits, and they're not going to. So we can't have either pollution cleanup at scale or cheap energy. We just can't have either one. But we can have both. That's the beautiful thing about it. If we make energy cheaper, buy more, clean up pollution, we get the volume discount. And that's the kind of thinking that we've got to have. By the way, focus on energy efficiency, which is very fashionable, only matters when we have fossil fuel energy. And we will end fossil fuel energy. So if we have abundant nuclear and renewable energy, energy efficiency really doesn't matter that much. So it's kind of a bad idea to waste our time on it. You know, you are the crew of Spaceship Earth, and it really is a spaceship. We are on a sun cruise together. We're going to circle the sun and come back to here next year. We better have accomplished something. But like any ship, there's an engineering team that's responsible for our gases and our liquids and our fluids and our food and taking care of our waste disposal. On a cruise ship, I know just who those people are. On a Navy ship, you know just who the engineering crew is. But I don't know who the engineering crew for Spaceship Earth is. And I don't think the job is actually that expensive. It's probably proportional to a cruise ship. But if we don't know who's in charge, we're probably not going to do a very good job. I'd also say who's driving the ship. And when we have these obstacles, it's a bit like, you know, a Navy ship being attacked by a torpedo. These climate tipping points like ocean acidification or methane clarate emissions or, you know, Arctic tundra methane emissions, we don't know. We can't expect scientists to be able to predict what tipping point is going to hit us first. But we still need to change our way. And if we put scientists in control, their job is studying reality. They're not going to tell us to turn the ship. You know, we need an admiral or a ship pilot that's willing to do the best they can in the face of uncertainty on schedule. And we're futzing around asking scientists what to do. Or we ask Wall Street what to do. That's even dumber. Wall Street always says, oh, sure, climate change is a problem, but we'll get around to fixing it, but not this quarter. We just want a good quarter. It's like a kid with a video game. That's all Wall Street's ever going to do, is worry about the current quarter. And with that kind of thinking, we are not going to succeed. One of the reasons I like working with startups for doing science instead of academia, I use both, but I really like the fact that with startups, you can focus on a task, bring a product to market, and you have a lot of focus. You also don't have distractions that you will at a big institution where everybody wants to coordinate with them. Like I was working at Microsoft and we shipped a beautiful new product in a new category. And the marketing people said, okay, but please delay the introduction until it goes out with the next version of Office from Microsoft, which it's incompatible with, all right? So, you know, the product was very unsuccessful being delayed so that it would be incompatible with the rest of the software. Yeah, that's the kind of thing that happens when you're dancing with elephants. So startups don't have to do that. They can work in secret. They don't have to tip off their competitors, and they can get patents and stuff. But mostly they can give key employees a lot of options, which makes them very successful if the entity succeeds. And that's the engine of Silicon Valley. We take technical people and give them so much money, they can start the next company without trying to convince bankers it's a good idea. And bankers never know what's a good idea. Their job is to take a business that's making money and make it bigger so that it makes more money. They're not interested in a business that's losing money, in their view, by investing in the future. The cons of startups are that you have to work in secret and you have to be buzzword compliant, do what the investors want you to do, and you sometimes want to claim that you're closer to commercialization than you actually are. But if you invest in a startup and it goes belly up, you may still be very happy about that, because if you invested in an academic research program, you wouldn't expect a return. And if you invested in a science-based startup that does advanced science, creates professionals, maybe it inspires its competitors to succeed even though it fails. You know, it's really hard to be one company in a new space, but if there's several competitors. So there's a lot of reasons you can declare victory even if the company fails. There's just not enough people who do this angel investing in startups. You know, if you have the opportunity to buy into something that has a 1 out of 4 chance of succeeding, that doesn't sound so great. But if you have 100x upside, if it succeeds, that's a pretty good, more than fair bet. Not enough people take them. Even when the government has a tremendous portfolio of clean energy assets, and one of them is Solyndra, that's the only one anyone remembers. So the portfolio did great. One failure, and everybody is saying, never do that again. If at first you don't succeed, never try again. So we really, now obviously the SEC doesn't want retail investors to lose their money, so they don't let most people invest in speculative companies like that. And that's a problem. We need more things like Indiegogo to help people support technology they think should exist, with a little bit of an upside. And so I meant to have this slide up just talking about the opportunities for speculative investments. Some people are worried that the government will be picking winners in technology. And I'm much more concerned about the opposite problem. Let's get the government to stop picking losers and doubling down forever. You know, we had a nuclear waste disposal site, Yucca Mountain, that seemed like a good idea at first. And then it turned out it wasn't dry, it was wet, and it was not popular, it was unpopular, and they just kept dumping money down that hole way, way, way too long, and we never did get a nuclear waste repository that we need, which a great example would be something like deep isolation that does borehole. It's very, very cheap. You can make money at it. The danger of doubling down on stupid is really serious. And am I advancing here? Okay, quick quiz question for you. Here's some trivia. This is my favorite number. Does anyone recognize it? 9 times 10 to the 16th power. You can almost put a dollar sign in it. It's a lot about your career. Any takers? Ever hear of an equation called E equals mc squared? What's c squared? So when you convert mass to energy by burning fuel properly, you get 9 times 10 to the 16th power energy out of your mass. So let's do that. In fact, if I get a telescope out and look around the galaxy, I don't see anyone using fossil fuels. It's all nuclear out there, guys. Someday we'll catch up with the space people. It's too wimpy to see. More seriously, the valley of stability is long and its walls are steep, and there's probably 100 kinds of commercially viable nuclear power that we haven't discovered because we haven't looked. We kind of decided it was a mature technology back in the 60s and haven't seriously innovated. It's time. I do think that it helps the debate to be clear about why so many nice, good, smart people tell awful lies and distribute fake news about nuclear power. And the reason is they think their competitors are doing it. You know, it's tribal. When I was in college, I was an anti-nuclear weapons activist, and I was particularly freaked out by this Peacekeeper missile. I basically accept the logic of mutually assured destruction, but it was clear to me that we had built 100 times more weapons than we needed for that logic. And then they wanted to add this one, which was a sitting duck. It could only be used as a first strike because it was in silos that were completely obvious where they were. So it was a very destabilizing idea. And I was worried that our government might have intentions to launch a first strike because of that. Why else would they build it? But they did build it, and then very soon thereafter they mothballed it because it really was a very dumb idea. And it was just a boondoggle. They didn't need the weapon, they needed to spend the money. So if we had been thinking more clearly, we could have had a lot of nuclear power plants, generators, anything else that we wanted with that money. Preferably you needed to find something that would involve the same contractors. But we lost more than just the money. We lost the opportunity to put engineers at work at stuff we really needed. We could have had cheaper rockets to get stuff into orbit. That would have been cool. But all we got was a weapon system that got mothballed. And they thought there'd be terrible layoffs in Southern California if the government stopped doing stuff like that. And the government did stop doing stuff like that. And it turns out those engineers in Southern California, they got other jobs. The economy grew quite a bit. It was not a problem to stop doing boondoggles like that. Now, light water reactor is what everyone thinks of as nuclear power, and it's good and great track record. I want to move beyond it because I don't like water in reactors. Water, if you only heat it to 300 C, a pathetically cool temperature, it becomes steam and gets 1,600 times bigger, which means you need a building that's 1,600 times bigger than your reactor vessel. That's a waste of money. And then that steam can turn into rocket fuel all too easily. Hydrogen and oxygen comes apart, floats to the ceiling of Fukushima and blows the roof off. Why have water in there? It's just not a good idea. Nevertheless, if we had done what France did in the 1980s, I think it's really important to think about the missed opportunity here, because France got decarbonized, all hydro and nuclear on their power grid in the 1980s. They didn't spend very much money to do it. And it's funny because, sometimes it's so foggy in Paris that you cannot see France. For example, at COP21, no delegate mentioned the fact that they were having a carbon-free conference in a carbon-free city in a carbon-free country. They couldn't imagine how you could be carbon-free until maybe 2050. I think the only person I heard that mentioned nuclear in a positive light there was Elon Musk. He wasn't an official speaker. That's why he could do that. If we had done that, we've done the numbers. There'd be 11.1 million people alive today that died because of air pollution from not accepting France's leadership on nuclear. 11 million people. Then there would have been 166 gigatons less carbon in the atmosphere. And that's just the power grid. If we had actually increased the use of nuclear power at that time, we also would have probably got our shipping and, as China does, we would have had building heating on nuclear. We would have had mineral processing. We could have pretty much done our complete net zero in the 1980s. And you know what? 3/4 of the human-caused greenhouse gases that are in the atmosphere today have been emitted since the 1980s. So that means that today you would not be seeing out of control, exponentially growing wildfires in California. You would not be seeing the intense hurricanes that we're seeing, the unprecedented tornadoes, the giant droughts. That was a choice we made by not going to nuclear in 1980 full court. It's a disaster. And if we never mention the fact that we could have taken a different road, that's not a good strategy. So casting blame around is not quite as good as an alternative approach, which is thanking people for good work. And our team built a site called gotnuclear.net, which has a little map of all the nuclear power plants on it, but it doesn't show you like you might be downwind and get a fallout cloud. Instead, it says how many people that plant has saved since it was built compared to the coal-fired alternative. And that is a really good number to know. You'll note there's about 1 million Americans that are alive thanks to our nuclear fleet. But in particular, I'd like to thank a fellow speaker, Kelvin Henderson, for being part of Duke Energy, because I clicked on just 2 of their plants. They have more. And I found out that those 2 plants have saved about 20,000 lives by providing clean energy and making it easy to breathe in North Carolina. So can we all thank Kelvin Henderson? And there are other kinds of nuclear power out there. I'm a big fan of President JFK's nuclear system, the molten salt reactor, and a lot of you know about that one. There's a bunch of companies doing it now. Unfortunately, he was, gunned down when he made a visit to the oil patch, but we could have been carbon negative by 2000 if we had built a gigawatt of week starting in 1980. We know why President Nixon decided to shut it down. It's not a conspiracy theory when you have tape. He recorded his thoughts, and what he said about the molten salt reactor's technical difficulties is, wherever possible, we should move the money to California. So its technical issue was it was in Tennessee and not California. Other than that, it was perfect. So we can overcome that kind of reasoning. We can build it today. It's ironic because I always say, never trust any technology over 50. And here I am promoting something that's like 60 or 70 years old, but so it goes. Those are my figures of merit about how much better it is. You guys know more about this than I do, probably. We also forget to mention that nuclear power is renewable, just like solar and wind. There's 450 million tons of uranium in the ocean that's easy to extract, and I just included a snippet from a recent article on one way to do it, but it's pretty easy. Economically viable, so there's no country on Earth that doesn't have uranium if they have access to oceans or can buy it from someone who does. And then there's an infinite amount of thorium for all practical purposes, and breeder reactors make any fuel infinite. Those work fine, always have. So it's important to mention that because when I went to school, they told us we only had 100 years of nuclear power, so it didn't really matter. And many people my age still think that it's a fossil fuel that's going to run out, not a renewable fuel that will last forever. These are just some of the details about the people behind the MSR. On the right, you'll see terrestrial energy, which we have Ken and Brian here, and other good companies like Thorcon and Seaborgium, I guess, and also the Chinese government is notable here. They're converting a coal-fired powered plant to nuclear using a molten salt reactor, which has the correct temperature for the job. It's hot enough to turn those turbines. If they like the taste of that, they might convert all their coal plants to be nuclear. And that's the way India could decarbonize quickly too. Because adding a nuclear power plant in India doesn't reduce carbon at all. To do that, you have to take out a coal plant. And you can only do that if you convert the coal plant to nuclear, because they need the power. They're not going to tear down one that works. So the fact that MSR is compatible with, the engineers will tell you that's a terrible way to build a power plant, and they're right. But the business people and the labor unions and the customers and the grid operators, they're going to say that's a terrific way to build a power plant. And those are the ones that matter. We should reach out to the health community because we have such a healthy product, and there's many people responsible for trying to keep people alive. And we don't always remember to remind them that we're on their side, so we have to reach out. I work with Eco America, as I mentioned. They have a big program on climate and health. And the Nature Conservancy here is a great ally because they are responsible for trying to increase the amount of land available to wildlife, and we're facing big problems with biofuels using a lot of farmland very inefficiently, and nuclear power is a much better option there. And then When I mentioned the job of pulling CO2 out of the atmosphere, it sounds hard, it is. We don't totally know how to do it, but air miners and drawdown.org are working at finding solutions for that, and we need to make sure they know that abundant, cheap energy is one of the tools that they can rely on. You know, the leaders follow when the people lead, and the good news is the people are noticing that climate change is scarier than the arms race. And in the last 4 years, according to our polling with Eco America, very scientifically, we have seen Democrats increase their support for nuclear from 37% to 60%, nearly matching Republicans that are at 65% consistently. So how many Democratic politicians know that their constituency has moved on and no longer hates and fears nuclear? Not very many. That's our job to let them know. Actually, the polling since 1998 shows 47% to 72% support. In this polarized era, how many things are there that 72% of Americans agree on? Nuclear is one of them. So you guys are in the right field. The industry of the future doesn't have lobbyists. Nobody is out there touting products that should exist but don't. And so we had to ask, if the molten salt reactor was on the market today, would you support that? And it turns out bipartisan support in America for advanced reactors. So it can happen. I love the science of fusion. There's many great companies out there working on it. And I'm concerned, though, that many of them are betting against fission. Fission works, the obstacles are mostly bureaucratic. I wouldn't make a whole company assuming that fission will never be approved. But they're doing new science in new areas. If they're going to succeed, they might have to pivot their business plan a little and get out of the electricity business. There is one kind of fusion that I do think has economic viability, and that is the oldest, actually. In 1922, Irons and Wendt published a paper at the American Chemical Society showing that they could make helium from a wire loaded with hydrogen that they exploded with a high current. Now, in 1922, the technology was kind of primitive. Their measurement tools were mostly the human eye and believing people. And there was a lot of controversy. Rutherford really hated it, tried to discredit them. But today we use exploding wires to initiate nuclear reactions, produces neutrons. It's not controversial. What was more controversial is in 1989, Martin Fleischmann and Stanley Pons tried to do the same thing except without exploding the wire. They figured if they put in a lot of deuterium in a palladium wire and stimulated it with electrochemistry, generating really high virtual pressures, they could make fusion happen. And they got a lot of excess heat. They did not get the expected particles for fusion. And so it was very confusing, and there was a catastrophic press release cycle where folks tried to replicate without even having the right paper, and MIT was able to prove it didn't work in less time than it would take to do the experiment, and all they had to do was shift their data down to make it look like they didn't have excess heat when they did. So those kind of false starts really hurt. The basic differences between fusion and solid-state fusion, or solid-state atomic and fusion energy, are listed sort of on this slide, but you know, there's a lamplight effect where you look where you can see, and plasma physicists are math nerds mostly, and the equations that govern fusion are beautifully precise. They're correct to like 9 orders of magnitude. And because it's 2 particle interactions, maybe there's a third particle that's a photon, you can wrap your calculus around that, get a perfect answer. Whereas solid state energy doesn't make those particles. So a fusion scientist, plasma physicist would say that's not fusion because I know what it is. It's a set of reaction steps, and the high energy radiation that should be the telltale is wrong. So it's not fusion. But a chemist might say, hey, I had some hydrogen, now I've got some helium, I got the right amount of heat out for it to be fusion, I call that fusion. So they're both right. It is fusion and it isn't, depending on your perspective. And we've had 33 years to study the reaction. We know the products, and we've had a lot of time to think about plausible theories. There's a basic idea of what the reaction steps are, and we're working hard on it. It could be commercial because there's no expensive materials. Most importantly, there's no radioactive materials produced or consumed, which means that the obstacles to deployment from the regulatory direction aren't there. They can't stop you from building a solid-state fusion system if you can build it. So that regulatory advantage overcomes a lot of scientific uncertainty. So I called out, this chart here has some of the institutions working on this. I called out Brillouin Energy and Clean Planet because I'm more familiar with them. I was introduced to this by the person that founded Brillouin Energy, Robert Gaddis, and I refused to talk to him for a whole year because I didn't want to have anything to do with cold fusion. But I did go study the backstory and figured out who was acting like a scientist and who was acting like an ideologue, and who was superstitious and arrogant. And it was really clear that the science was on the side of the so-called cold fusion researchers. And so then I was willing to meet him and decided that I didn't believe him, but I figured it should be tested in a better calorimeter. So I gave him money for a real calorimeter, and then it still worked. And over the years, he's raised at least $20 million, and now thinks he has a little Stirling engine that's powered by energy from solid-state fusion, which, ironically, most American physicists say must be a fraud, can't possibly work. So if you love studying the history of science, this is one chance to watch a paradigm shift in action. There aren't that many days when you know something that most physicists disagree with. So it's a rare opportunity to enjoy the battle. In broad strokes then, the 4 kinds of nuclear that I like to divide it up. The first one, light water reactor, is great except for financing in the US. Hey, the South Koreans and the Chinese can build these and make money. Somehow the United States can't. That's fixable. The second line is the water-free reactors, the advanced reactors. The only thing wrong with them is the Nuclear Regulatory Commission has successfully blocked them for 50 years. Any day now that could change. Bring it on, please. Third line is fusion, hot fusion. I see a big science, engineering, and even regulatory obstacles there, finance obstacles. The first one is going to break. It costs billions of dollars. Who's going to build the second one? I don't think so. And then the fourth line is solid-state fusion. And the only problem there is science. We don't totally understand it. And that is a problem, but it's the kind of problem I like to have because it doesn't cost very much to solve, and once you figure out the science, it never costs you a dime again. And I can refer you to a bunch of wonderful publications in this area. I'm going to kind of skip forward here. I'm very thankful the Department of Energy has been supporting this work in solid-state energy. They had a workshop in October that was well attended. It had fantastic people. NASA's been supporting it very well because they need power for deep spacecraft, and the Department of Energy can't or won't supply them plutonium at a reasonable price. Plus, it freaks people out when they launch it over the heads at Cape Canaveral. So these kind of fusion-fission systems are a lot safer and more popular. We've got, unfortunately, we were going to offer a STEM kit, so students in bachelor's or graduate programs would be able to get the materials that they couldn't make to demonstrate the solid-state energy fusion reaction in their own labs and play around with it, see if they could control it in various ways. You can see we're promising that it'll be available in 2019. Sorry, still working on it. The NASA people couldn't go to their laboratory for 2 years. And lots of press on the issue. And I'll skip over these. One nice thing, First Light Fusion is a nice hot fusion company, well respected, but the Sono Fusion thing that they're using has been mostly a product of the cold fusion community rather than the traditional physics. So along these lines, I would like to personally invite you to the 24th annual conference on cold fusion in Silicon Valley, Mountain View. I am the chair of this time. It's a great honor for me. And the conference alternates between Asia, Europe, and America. So this is the 1 out of 3 years that it's in America. And we'll have it at the Computer History Museum. We also have a hybrid option that should be excellent. And a lot of great speakers from a lot of different agencies and different companies. We should have a live demo of a system that actually works. And so that's about what I brought with you today. I guess I was asked to provide some career advice too. And I think that the reason I usually advise people to go into software because it's such a quick changing field that a young professional going into the field doesn't have to worry about the experienced people. You don't have to wait 40 years for everybody else to retire. But the beautiful thing about nuclear energy right now is there's so much in the way of new tools, new materials, new reaction chains, and actual competition in the marketplace that it is an extremely vibrant place. I had trouble putting my slides together because they were going obsolete on a weekly basis. So this is an amazing moment to be in this field, but don't be shy about being disruptive and trying to work with people who are really changing things. And there are a lot of old institutions in there. I like to say that we have 2 political parties in America. One is trying to protect the shareholders and investors and executives in the big old companies that are blocking progress. And the other party is trying to protect the labor for the big old companies that are blocking progress. And there are ways of making progress happen, but you have to be a little bit like a pirate ship. And disrupting things is not impossible. You have to know you're doing it. And I think about how you can actually get the stuff done that you want to get done and how to be disruptive. Because we know what'll happen if Wall Street's in charge. We'll get a good quarter every quarter until society collapses. So thank you very much for your kind attention. And with that, I'll be around and I'm excited to hear from the rest of you. And again, my notes will be online. So thanks.